additional symmetry properties. Here are the first three. Notice here that the pi on 2's, we've got pi on 2 minus theta, pi on 2 minus theta, and sine, cos, and tan. And we've got various answers here of sine pi on 2 minus theta is equal to cos theta, cos pi on 2 minus theta is equal to sine theta, and tan pi on 2 take away theta is equal to 1 over tan theta. So there's a couple of things you might be aware. This is the first time that we've dealt with anything that's not pi minus or pi plus or 2 pi minus or 2 pi plus or anything like that. This is a difference. It's weird. This is minusing from the vertical axes. Another thing you might notice is it says 1 over tan theta. Now, for those who have done any extra study, particularly with specialists, will know that this is also sometimes referred to as cot theta. You don't need to know that for methods, but that's just a fun fact if you see it in any other reference. So how do we know that these relationships are so? How do we know that these formulas are? Well, let's go and prove it with a diagram. Here I've got a right angle triangle. This right angle is, of course, pi on 2. And let's label this as theta. So what would the other angle be? Well, I know that all the other angles, or all angles, I should say, in a triangle add up to 180 degrees, or pi. So this angle will be pi, take away pi on 2, take away theta. Or in other words, 2 pi on 2, take away pi on 2, take away theta. 2 pi on 2, take away pi on 2, just leaves me a pi on 2. So I can label that angle up here as pi on 2, take away theta. What I'm going to do now is I'm just going to go and label the sides A, B, and C as I wish. A, B, and C. Well, if I was wanting to do if I was to do, say, sine of the angle here, of this one at the bottom, in fact, I might even color code this one here. Well, that's going to be opposite over hypotenuse, which would be B over C. So the vertical side over the hypotenuse. Well, that, if I was to do cos of pi over 2 take away theta, which is that top corner here, that is adjacent over hypotenuse, so that's also equal to B over C. So hence, those things are equal. If I have cos of the angle, well, that's equal to adjacent over hypotenuse, so that's going to be A over C. And using that same logic, sine pi over 2 take away theta, well, that's equal to opposite over hypotenuse, and that's also equal to A over C. So therefore, those are equal to each other. As for the tan, so tan is equal, so where did we pull the tan from? So tan of the angle, we know, is equal to, so opposite over adjacent. So let's write that down. Tan of the angle is equal to opposite over adjacent, which is equal to B over A. So here we go. So there's the value there. So in fact, I should just keep that color coding up. So therefore, tan of pi on 2 take away theta, again, that's opposite over adjacent, and that is equal to A over B. So in other words, it's the upside down version of the first tan then. So that is our diagrammatic proof. We could also use some algebra, and we'll probably be using the algebra to go and prove the other ones. But this is sort of the basic principle behind having pi minus 2 and the symmetry properties within. You'll notice that this time we've got pi over 2 plus theta. And this makes it a little bit more difficult to show with a diagram. So I'm actually going to use the CAS calculator to help me out. In this particular example, I'm just going to suggest an e.g. That theta is equal to pi on I'm just going to use a proof using, well, this wouldn't be a proof, this would be a verify. So let's go and get this. I'm going to verify this. And the reason why it's not a proof is I'm not going from first principles, I'm just substituting in. So let's just, for our knowledge sake, so find out what just sine of pi on 4 is. Hopefully we'll remember our exact values, but just in case we don't, there is sine pi on 4, which is equal to root 2 on 2. And cos pi on 4, what would that be equal to? Let's drag that down. And that is equal to root 2 on 2, because of course they are in that square, the one with the same sides, the triangle that has the height of 1 and the base of 1. So now that we've done that, let's see what happens when I put sine pi over 2 plus pi over 4. Look at that. It's still equal to root 2 over 2. In other words, it's equal to the same as cos theta. If we, and we'll substitute with another angle shortly. So if I do cos pi over 2, plus, you notice there it's become negative. So there is one sort of suggestion. So what I'm going to do here is I'm now going to go with another example here. So instead of pi over 4, I'm going to go with pi over 6. I'm going to verify using pi over 6. So as a reminder of what those equal to, so sine pi over 6 is equal to a half. But cos pi on 6 is going to be very different. It's going to be pi on 6, and that gets us root 3 on 2. So what we're going to do is we're going to see what happens when I do sine pi over 2 plus pi on 6 and cos pi on 2 plus pi on 6. And I get root 3 on 2, and I get negative 1/2. So you'll notice there that they have become the opposite values. So it has cos pi on, that's become cos pi on 6. This has become negative sine pi on 6. As for the tan value, this is a little bit harder to show, but hopefully we can see here. So if I've done, so now that you realize what we've done here, what we'll do is we'll clear this, and we'll have, say, tan so there's tan pi on 6, so it's root 3 over 3, and what we'll do is we'll show you what negative 1, so and negative 1 over tan pi on 6 is equal to negative root 3. So if I do tan pi on 2, so tan pi on 2 plus pi on 6 gets us negative root 3. So there is our verification to see that this is in fact true. Also, we could have done that same proofing by doing a division, because with that tan, don't forget that tan would be equal to sine pi on 2 plus theta over cos pi on 2 plus theta, which of course, given the things that we have discovered already, would be equal to cos theta divided by negative sine theta. So in other words, negative 1 over tan theta. So that also will show it too. Once we get 3 pi over 2, and there might be questions about this, involving 3 pi and 2, essentially all that happens between that and pi and what you've noticed there before is that it's just reflected all of our answers in the x-axis. And that is because, of course, 3 pi on 2, if we bring up our unit circle, there's 3 pi on 2. It is underneath the x-axis. So therefore, all of the values, all of the things that we worked out will just become the negative version. So for example, we had established that pi over 2 minus theta gets us all of these values. They're all positive. Well, once I use 3 pi over 2, they go negative because they're upside down. The only one that's not gone negative is tan 3 pi over 2. You'll notice that it hasn't gone negative. It is positive 1 over tan 2 because tan is sine over cos. So this would be equal to negative cos theta divided by negative sine theta. Why is that? Because it will be sine 3 pi over 2 take away theta divided by cos 3 pi over 2 take away theta. When you divide those, it's the same as dividing these answers here. And so the two minuses will cancel each other out and it'll be an upside down tangent. Similarly over here, when we're adding theta, then we're just changing those plus and minus signs around, but the tan will still be the same as it was at the top. So there's some additional symmetry properties.